Literals. In Python, literals are of several types and their usage is also pretty varied. So let us check them out one by one. There are 5 types of literals in Python, which are as follows: string literals, numeric literals, Boolean literals, literal collections, special literals. Here is the flowchart of types of literals. String literals in Python. Let us discuss string literals in Python now. Creating a string literal in Python is really easy. Enclose the text or the group of characters in single, double, or triple quotes. Using triple quotes also allows us to write multi-line strings. Hence, we can say that there are 2 types of string literals in Python. Single line string. String literals are enclosed within single quotes, and these are known as single line strings. The example of single line string is as follows. And we get the output accordingly. Multi-line string. A collection of characters or strings that goes on for multiple lines is a multiple line string. Using triple quotes at the beginning and the end of this string will allow us to create a multi-line string in Python easily. Here is an example where we use multi-line strings. Numeric literals in Python. Numeric literals in Python are those literals that contain digits only and are immutable. There are 4 types. Integer. The numerical literals are 0, positive, or negative natural numbers. They contain no decimal points. The different types of integers are decimal, binary, octal, and hexadecimal. Float. The floating point literals are also known as real literals. Unlike integers, these contain decimal points. Float literals are primarily of 2 types: fractional and exponential. Complex literals. These are represented by a plus bj. Over here, a is the real part and the entire thing along with g is the imaginary or complex part. J here represents the square root of -1, which is nothing but the iota or I which we use in mathematics. Long literals. These are nothing but integers with unlimited length. Long literals are represented with a suffix L. The usage of L was strongly recommended as it looked a lot like the digit 1. Boolean literals in Python. Boolean literals in Python are pretty straightforward and have only 2 values, that is true and false. True represents the value 1. False represents the value 0. Here is an example where we use Boolean literals and the output has true and false accordingly. Special literals in Python. Python literals have one special literal known as none. This literal in Python use it to signify a particular field which is not created. Python will print none as output when we print the variable with no value assigned to it. None is also used for end of the list used in Python. Here is an example where we get the output as none. Literal collections in Python. There are different types of literals and we include 4 of them: list literals, tuple literals, dictionary literals, and set literals. And next comes our topic, keywords. You can get a list of available keywords by using help. That is, help of keywords within the double quotes. Here is the list of Python keywords. Enter any keyword to get more help. They include false, none, true, and, as, assert, async, await, break, and so on, as you can see here. Python also provides a keyword module for working with Python keywords in a programmatic way. The keyword module in Python provides two helpful members for dealing with keywords. First one, the KW list, and second, is keyword of. The KW list, it provides a list of all the Python keywords for the version of Python you are running. Is keyword provides a handy way to determine if a string is also a keyword or not. Value keywords: true, false, or none. There are 3 Python keywords that are used as values. These values are singleton values that can be used over and over again and also reference the exact same object. You will most likely see and use these values a lot in Python further. The true and false keywords. The true keyword is used as the Boolean true value in Python code. The Python keyword false is similar to the true keyword but with the opposite Boolean value of false, which is obviously the opposite in meaning. In other programming languages, you will see these keywords written in lowercase, true and false. But in Python, they are always written in uppercase. Operator keywords: and, or, not, in, and is. Several Python keywords are used as operators. In other programming languages, these operators use symbols like ampersand, a bar, and an exclamatory mark, which we use in our common language. They have their own names in Python. The Python operators for these are all keywords. Here is a table which gives us information about math operator, other languages, and the Python keyword. The AND keyword. Python keyword AND is used to determine if both the left and right openings are true or false. If both the operands are true, then the result will be true. If one is false, then the result will be false. The OR keyword. Python's OR keyword is used to determine if at least one of the operands is truthy. Truth is nothing but true. An OR statement returns the first operand if it is true and otherwise returns the second operand. The not keyword. Python's not keyword is used to get the opposite Boolean value of a variable, which is if the input is true and we include a not true, then the output is false, and it works in the opposite similarly. The in keyword. Python's in keyword is a membership operator. Given an element to find and a container to search, in return true or false, indicating whether the element was found in the keyword. The is keyword. Python's is keyword is an identity check. This is different from equal operator, which is equal to in Python. It checks for equality. Sometimes two things can be considered equal but not be exact same object in memory. The is keyword determines whether two objects are exactly the same object. The next topic, identifiers. Identifiers are the names given to variables, classes, methods, etc. Python is a case-sensitive language. This means variable with a capital V and variable with a small v are not the same. Always give the identifiers a name that makes sense. While C equals 10 is a valid name, writing count equals 10 would make more sense and it would be easier to figure out what it represents when you look at your code after a long gap. Rules for naming an identifier. An identifier cannot be a keyword. Identifiers are case sensitive. It can have a sequence of letters and digits, however, it must begin with a letter or underscore. The first letter of an identifier cannot be a digit. It's a convention to start an identifier with a letter rather underscore. White spaces are not allowed. We cannot use special symbols like exclamation, at, hash, dollar, and so on. Here are some valid and invalid identifiers in Python. They include valid identifiers, score, return value, highest score, name1, convert to string, and invalid identifiers, at core, return, highest score without underscore, one name, convert to string, which doesn't include an underscore here. The next topic, variables. In programming, a variable is a container, that is a storage area to hold the data. For example, we are assigning 10 to a variable named number. Here, number is a variable storing the value 10. Assigning values to variables in Python. As we can see from the above example, we use the assignment operator equals to assign a value to a variable. The example is as follows, and you get the output accordingly. Rules for naming Python variables. Constant and variable names should have a combination of letters in lowercase, that is A to Z, or uppercase capital A to Z, or digits 0 to 9, or an underscore. Create a name that makes sense. For example, vowel makes more sense than V. If you want to create a variable name having two words, use underscore to separate them. Python is case sensitive, so num with small n and num with capital N are the different variables. Avoid using keywords like if, true, class, etc. as variable names. So, we are done with our topics keywords, literals, variables, and identifiers. Thank you.